Asphalt paving is every bit as important to local roads and streets as it is to state and interstate highways. And proper inspection of the work is just as critical. It's your job to ensure that the citizens of your community get the high-quality asphalt pavement they deserve. This videotape training has been developed as part of the Local Technical Assistance Program, LTAP. It is designed to give you, who are responsible for construction and maintenance of the local road system, the information you need to effectively inspect asphalt paving operations. In addition to the video, there's a checklist to remind you of the key inspection points. Now, because of our country's move to metric measurements, we're going to use metric units throughout this presentation and in the checklist. The video is in 3 parts, so after a few minutes of viewing, you can discuss what you've just seen and heard. All 3 parts are on this tape. Here in Part 1, we'll look at your responsibilities before paving begins: document review, coordination with the public, field review, equipment checks, traffic control, and weather requirements. Then, we'll look at inspecting the tack coat application. Part 2 covers the paving operation itself. And Part 3 shows some of the problems that can occur with mixed quality, laydown operations, and rolling. So let's get started. Document review. First, as with any project, review the contract documents. This includes your agency's bid specifications, including amendments, any special provisions, the appropriate sections of the construction manual, and the traffic control plan. Paving details can vary significantly from one job to the next, especially for traffic control. The traffic control plan identifies the types of signs and devices necessary, as well as their placement. So always study it carefully. And remember, no changes should be made to the traffic control plan unless the changes have been approved in writing by your agency. After reviewing all the project documents, find out what plans have been made to coordinate the paving operation with the utilities, businesses, and residents who will be affected. As necessary, utilities may have to be notified early so that arrangements can be made to adjust manhole elevations. Also, any planned crossroad utility cuts must of course be completed and patched before the new pavement is placed. Businesses should be contacted to arrange access times for employees if entrances and exits will be blocked by the paving operation. Private residents must be notified too. As the inspector, you should check out all such arrangements before paving begins. You should also take time to review the field conditions. The first 2 rules to remember are: always wear a safety vest when you're working near equipment or traffic, and always remember where you are. Even though a vest will make you clearly visible, a few steps in the wrong direction could be fatal. Some areas of the existing surface may need to be repaired before the road is paved. The locations and extents of these defects, such as potholes and areas needing pre-leveling, are typically marked on the pavement. See to it that this repair work is done properly. Along with pothole repair and pre-leveling, many projects specify milling. Milling is often used in urban areas so that the new pavement will match up with existing manholes and curbs. This procedure is also effective in eliminating wheel ruts. When milling is required, your first major concern is that the pavement is milled to the proper depth. Also, be sure that the milling equipment does not tear or rip the surface. In addition, make sure that the contractor takes appropriate measures to control dust and to maintain proper drainage from the pavement. Once the surface is properly prepared, your next preliminary responsibility is to check the paving equipment. First, get familiar with the equipment that will be used. The paving train consists of haul trucks, a paver, and 2 or more rollers. A distributor applies the tack coat to bond the pavement to the underlying surface. A power broom sweeps off the surface ahead of the tack application. Now let's take a closer look at each, beginning with haul trucks. There are 3 types: belly dump, rear dump, and conveyor. Regardless of the type of truck used, a major concern is fuel and oil leaks that can contaminate the mix. So spot check all trucks before paving begins and from time to time during paving to see that there are no leaks. When rear dump trucks are used, look around the hydraulic rams and connections too. Leaks this severe are unusual, but they do happen. If you find a leak, see that the contractor takes whatever measures are necessary to remove the spillage ahead of the paver. And of course, the equipment should be removed from the project and repaired. For safety, be sure that all truck backup alarms work properly. Another concern with haul trucks is the use of tarps to cover the mix. Tarps may be required to keep the mix hot or to keep out dust that would contaminate the load. Finally, contractors typically use a releasing agent to keep mix from sticking to truck beds. Be sure that it's an approved non-petroleum agent. Diesel fuel or other petroleum solvents must never be permitted as releasing agents. They dissolve the asphalt in the mix. To keep the mix from becoming contaminated, the releasing agent will have to be drained off completely before the mix is loaded. Although this is an inspection concern at the plant, you too should be on the lookout for contaminated loads at the job site and notify the plant if you see any. Okay, now let's look at the paver or laydown machine. There are many types, but all consist of a tractor and a screed. The tractor, of course, provides the power and includes a hopper where the mix is deposited. The screed's functions are to smooth and partially compact the mix. When belly dump trucks are used, a pickup machine is attached to the front of the tractor. Let's take a closer look at each component, beginning with the pickup machine. As you can see, it's pretty basic. The wings on each side of the machine are used to channel the mix toward the paddles, which in turn load the hopper. A plate is mounted below the paddles to ensure that all the mix is picked up. Rear dump and conveyor trucks load the paver directly. 2 push rollers mounted on the front of the hopper push the truck along as the truck loads the hopper. Inside the hopper, 2 flight chains carry the mix through the tractor. The flow control gates over each chain are adjusted to allow the right amount of mix to pass through. As the mix comes out of the back of the tractor, the auger distributes it evenly in front of the screed. On many pavers, paddles are mounted at the center of the auger to keep material flowing toward the edges. A slope shoe, like you see here, may be attached to the screed to bevel the outside edge of surface courses. And that brings us to the screed unit. The screed acts independently and is pulled by the tractor. It strikes off the mix and partially compacts and smooths it through its vibratory or tamping action. See that the surface of the screed is smooth. A warped screed, or a screed with worn edges, can rip the new surface or cause the pavement to be uneven. You should also check into the adjustment of the screed. All pavers are equipped with adjustment bolts for the leading and trailing edge of the screed. Some pavers are also equipped with indicators so you can easily see the adjustment settings. The leading edge of the screed should be set slightly higher than the trailing edge, by about 10 millimeters initially. This presses the material under the screed, where it is struck off, partially compacted, and smoothed. Many screeds can also be extended and retracted to accommodate various paving widths. If such an extension is being used, make sure the auger is the same length as the extension. If the screed is manually controlled, there will be 2 screws that are used to control the depth of the mix being placed. These should be set at the beginning of the work and rarely adjusted during the operation. Another function of the screed unit is to regulate the grade and cross slope of the mix being placed. That's important. Maintaining the proper grade and cross slope are critical in getting a quality pavement. So many pavers are equipped with highly sensitive electronic devices for controlling both grade and cross slope. Some agencies require that the grade be controlled with a sensing device and a long ski. The ski provides a moving reference for the sensing device. The sensor is located in a small box with an arm extending below it. The arm rests on the ski and detects bumps or sags in the surface. Then, through electronics and hydraulics, the screed is automatically adjusted to provide a smooth surface. To get the best results, the sensing device should be mounted between 2 and 3.5 meters ahead of the screed. The cross slope is controlled by a sensing device mounted on the screed and connected to the control mounted on the tractor. The cross slope needed for the particular job is preset, so that the sensor can continuously adjust the screed to maintain the proper cross slope. There's a lot more involved with grade and cross slope control, but we'll look at both in more detail when we get to the paving operation. Now let's look at the rollers. There are many types, but all can be classified as steel-wheeled or pneumatic-tired. For leveling courses, a pneumatic-tired roller works best because the kneading action of the tires works the mix into the depressions. Steel wheels, on the other hand, tend to bridge the low spots and not compact the mix as well. All other courses can be rolled with steel-wheeled rollers or a combination of steel-wheeled and pneumatic-tired. The main point with rollers is that the compaction requirements have to be met. The contractor needs enough rollers of the proper weight, in good condition, and operated properly to achieve compaction without damage to the mat. So let's take a closer look at the rollers, starting with steel-wheeled. The 2 most common types are 2-wheel and 2-wheel vibratory, although you may see 3-wheel rollers as well. The vibratory rollers can be operated either with or without vibration. The vibratory mode is used in the beginning of the rolling operation because it provides the most compaction. The static mode, that is without vibration, allows the same roller to smooth out the pavement. The first thing to check on all steel-wheeled rollers is the drums. If they're not smooth, there's just no hope for a smooth pavement. You should also check the scrapers and mats. They remove mix that sometimes sticks to the drums. If it's not scraped off, this mix can mar the pavement surface. The drums also have to be kept moist, so make sure all the sprinkler nozzles are working. And finally, look under the roller. Make sure there are no oil or fuel leaks. Either kind of leakage will contaminate the mix. And that covers steel-wheeled rollers. Now let's look at pneumatic tired rollers. Tire pressure greatly affects the performance of these rollers. All tires must be inflated to the same pressure within the tolerance suggested in the checklist. In addition, these rollers should have a working weight capacity of at least 115 kilograms per 6 centimeters width of tire tread. So measure the width of the tires and divide the number of centimeters into the total weight of the roller. Your checklist covers these calculations in detail. Now let's have a look at the hand tools required. Only lutes and shovels should be used. Lutes are used primarily in constructing longitudinal and transverse joints. The important thing is that it's lutes, not rakes. Rakes are shaped differently and cause segregation of the mix. They just don't do the job properly. Just one more point about hand tools. Most contractors store them in containers filled with diesel fuel. That's perfectly acceptable, as long as the fuel isn't spilled on the mat. While the hand tools are in use, however, they should be cleaned with a putty knife, not with the diesel fuel. And they shouldn't be cleaned by scraping them off on any part of the laydown machine either. And those are the equipment checks. Now let's look at traffic control in a little more detail. As you heard in the beginning of the program, a traffic control plan should identify the types of signs and devices to be used and where they should be placed. So you should always inspect them as they're set up to be sure they comply with the plan. Now, although the exact signs and devices and their locations will change from project to project, there are a number of principles that apply to all traffic control zones. First, the traffic control setup should comply with the manual on uniform traffic control devices. Second, when traffic has to be alternated through the work area, make sure the flaggers work together to avoid holding traffic too long. Third, report any unsafe conditions to your supervisor as soon as possible. And fourth, make sure all signs are removed or covered when they no longer apply. Motorists learn to ignore signs when they don't see any roadwork. Your final preliminary concern is the weather. Temperature, precipitation, and wind are factors in determining whether or not to pave. Most agencies require a brief documentation of daily weather conditions on paving projects. To begin with, the mix should not be placed when temperatures are too low. Check the specs. Many agencies base their limitations on air temperature, others on surface temperature, and some use both. Cold temperatures, of course, will cool the mix, making it difficult to get adequate compaction. In addition, the fresh mat may not adhere to a cold surface, so always check the actual temperature with a reliable thermometer. You should also be aware that many agencies have calendar date restrictions, such as no paving allowed after October 15th, or before April 15th. These restrictions are provided to help prevent the problems associated with low temperatures. Again, be sure to check your agency's specs. Precipitation is a concern. Asphalt paving should not begin when rain is about to fall or too soon after it's fallen, while the surface is still wet. Occasional sprinkles or passing showers have to be dealt with according to their volume and duration, from working right on through the minor ones to temporarily halting for the more serious ones. Winds by themselves may not be cause to avoid paving, but they sure can mess up the tack application and cool down the mix real fast. So use good judgment. If weather conditions prevent good work, take the necessary action. Now we'll look at the last item on the list, the tack coat. The purpose of the tack coat is to bond the new pavement to the existing pavement. So first, it's very important to thoroughly clean the surface. And then cover it uniformly with the right amount of tack. But there is a lot to inspect. To begin, check the contract documents to see what type of tack material is to be used. Most agencies require emulsions, but some use asphalt cement or cutback asphalt. As inspector, you may have to sample the tack. If so, be sure to follow your agency's procedures for collecting, documenting, and submitting the samples properly. Next, find the application rate for the tack coat in the contract documents. Many agencies will allow you to make small adjustments in the application rate depending on the condition of the surface. Basically, you'll always use more tack on old and milled surfaces than you will between new courses. Then, record the number of liters in the distributor so that later you can calculate the application rate. You'll also need this information for payment purposes. Before the material is applied, see that the surface is both clean and dry. Otherwise, the tack won't bond the new pavement to the existing surface. Then, verify that the tack material has been heated to the proper temperature. The contract documents typically give a temperature range. Also be sure that the distributor's pump pressure is correct and constant according to the manufacturer. Next, look at the spray bar, starting with the nozzles. They all have to be clean and angled in the same direction to get the proper coverage. And check the height of the spray bar. The proper bar height, nozzle angles, and application pressure determine the quality of the tack spray pattern. Generally, you want a double or triple lap coverage. This is a good tack application. Smooth, even, and uniform. Look over the application closely. If you see any bare spots or lightly covered areas, stop the distributor and get the problem corrected. It could be just one plugged or misaligned nozzle, so make the necessary adjustments. After the material has been applied, be sure to record the number of liters remaining so you can calculate the application rate. To do this, you divide the number of liters of tack applied by the area covered. The length of application times the width in meters. The rate is so many liters per square meter. Here are some more points about the tack coat. Don't apply more tack than can be covered the same day. Also, be sure traffic and dirt are kept off the tack coat. Both will hamper the bond. When emulsions are used, make sure the material breaks, loses its water content, before the mix is placed on the surface. You know this has happened when the tack turns from brown to black and becomes sticky or tacky. When asphalt cement is used, the mix can be placed immediately. However, when a cutback asphalt is used, it must first cure. That is, the solvents must evaporate. You can check the application with your finger. Before a cutback cures, your finger will pick up an oily film. After it cures, there's no oily film, and the surface is tacky or sticky. With that, we've covered your preliminary inspection responsibilities and the tack coat application. In Part 2, we'll look at the paving operation itself.